is what I have online. So if you haven't already done so, this is the module final exam information. Our exam is going to be Wednesday, 12 till 3. If you get in 10 minutes early, you can get started. That'll give me a chance to make sure that all the PDFs are up and running. So if you're here, you can just get started as soon as they're verified. If you click on the top one, it basically gives you a rundown of the topics and so on, and how the exam is going to, the final exam is going to work. If you click on this one, there's the Zoom link that you'll go and use. If you click on this one, this is where you will find the 20 multiple choice questions. But you won't have anything there, of course, until the day of the final. And over in WebAssign, there'll be another one. So I would do the PDF first, right? The Canvas 20, write all the paper, you know, all you do is write the answers down. Question 2 is A, question 3 is C, and then go over to WebAssign and do your 10 questions there and write down all the working, including whatever you write down in SALT. That's important. And then once you've done the entire final, you upload it there. And hopefully it'll be good to go. Okay, anything? Okay, I got you. Someone's internet, Rob's internet is not very good. So go for it. Tell me, ask me, whatever. What do you want me to do? Any topics, any homework question, any test question? What you got?
For some reason, if you look at my homework, I turned in for 13B, or the sample means, I can't even say it, the difference in sample means.
Right, so hypothesis single mean.
I'm having problems writing the null hypothesis and alternate hypothesis in WebAssign.
Okay, let me find your question, Sean. And here we go. Oops, hit the wrong button. No, that's not a big problem. Hit the right button. There we go. And it's hypothesis testing for the difference in two means, correct?
Right.
Okay, so let me click on one of those guys. And have you a specific question that you were having trouble with? It looks like you're trouble with 5 and 6, for instance.
Okay.
Okay.
It looks like I had trouble with a whole lot more than that, but
well, we'll start with 5.
okay.
We'll try and mix and match it so that other people get a thing. So I'll do question 5, then I'll see what other, you know, somebody else's question, then I'll come back and do
Perfect.
6. Right, so in question 5A, you're told X1 bar. You were told X2 bar, so that's the mean of the two samples. You were told the standard deviation is sample 1, which is 9. And you're told the standard deviation is sample 2, which is 8. And you were told the sample size for the first group was 81, and N2, the sample size of the other group is 64. And we're being asked to get the t-score. Right, so first thing is, do you know the formula for getting the t-score in this situation? I don't know if it's your internet going out on me or you're not sure. Do you know the formula for calculating the t-score for the difference between two samples?
Not between two samples. That's what I was having problems with.
So
one
here
sample,
we
I know
go.
how to
It's
do it.
X1 bar, take away X2 bar, divided by the standard error of those two. Now, in this case, X1 bar is 35 and X2 bar is 32. And then there's this guy called the standard error, and I'm going to do him separately over here because he has his own formula as well. Now, to get the standard error for the difference between two means, which is how that is basically written, it's the square root of S1 squared over N1 plus S2 squared over N2. These are the kind of formula that you really want to have written down somewhere. Have a couple of pages of paper where you put nothing but the various formulas that you know that you've seen. In this case, it's 9 squared divided by 81 plus 8 squared divided by 64. If I go to my calculator, although I could probably do some of that in my head because the numbers are really nice, but just to show you what you would do even if the numbers weren't nice, you do the square root of 9 squared divided by 81 plus 8 squared divided by 64, and you should get 1.414. There we go. Now, once we know the standard error, we return back to this formula. And the standard error is 1.414. Now, the next place you could go wrong is that when you have a calculation like this, it's a good idea to remember that the top needs brackets. So you go bracket 35, take away 32, close the brackets, and then divide by that guy. And when you do that, the answer 2.12 to 2 decimal places. And that is the correct answer to 5A. Now, if you were doing this in a final exam, I would definitely want to see all of that. And I'd also want to see how you got the standard error. You do not need to write down these numbers because they are part of the question. I know what those numbers are, but you do need to write down the formula that you're using and the numbers that go in each of these locations. And for the standard error, that guy.
And 212 is the correct answer.
Yes.
Okay, that's what I got this time.
Right, 2.12.
Right. Okay, thank you.
Okay, so we'll come back to your next question in a second, but someone else got their own question as well. Do you have any questions?
I do. It's going back to the second exam. The
Sure.
last question I had on the exam, I could not figure out how to calculate it right. Number 7.
Okay, so it'll take me a few seconds to find that guy. So test 2, right? That's going to be in a past life. Let's see. Test 1, gotcha. Test 2, gotcha. Let's do scores on test 2. Let's pick yours, that way I'll have the same numbers that you had. Okay, we'll click on that. And what question was it again?
Number 7.
7. Okay, the last one. So it says, suppose you're interested in estimating the average number of miles per gallon of gasoline your car can get. You calculate the miles per gallon of each of the next 21 times you fill the tank. Okay, so basically your sample size is 21. Suppose that in truth, the value of your car is bell-shaped. Well, that's nice to know. The mean is 22 and the standard deviation is 1. And then it's asking us to find a 68, a 95, and a 99.7 based on this information, right? So when it's a 68, isn't it going to be the mean plus or minus 1 standard deviation? And then the mean plus or minus 2 standard deviations? And then the mean plus or minus 3 standard deviations? Remember that guy, 1 standard deviation gets you 68. It's called the 68, 95, 99.7 rule. So I really just need to plug together the numbers that we've got. But in this world, the standard deviation is a sample standard deviation. So we have to put in this square root of n. So it's going to be 21 plus 1 over the square root of 21, then 21 plus 2 over the square root of 21, and then 21 plus 3 over the square root of 21. And that extra little bit kind of, oh, by the way, it's plus and minus. So that extra little bit does change your answers a little bit. So for instance, this one here, if you take 21 and subtract this fraction, you get 20, you don't get 20. Yeah, you do. You get 21.782. And if you add it, you get 22.218. So the key was to think of this as a sample. And when you do the sample standard deviation, it's sigma over root n. And that was it.
That's what I missed. That's why I couldn't get it. Okay.
Okay.
I believe Errol had some questions.
Okay, maybe hers are in the chat. Okay. On the final practice number 15 to 18, isn't positive stroke negative correlation the same as correlation of 1 and negative 1? Okay, so let me 15 to 18. I'm assuming, Ariel, that you are talking about the multiple choice question. Is that right? Okay, so let me get that one up on the screen. We can all have a look at it and we'll see what's going on here. Right, so this one here? No, that doesn't make sense. What question number is it? Let me, I can't see. I have to go out so I can find the chat to find out which one it is. So 15 to 18, okay, gotcha. Are we still looking at the final practice thing, or will I have to go and reload it up? Can you see the practice final questions with solutions?
It is no longer on your screen.
Okay, so I do need to go back. Right. Right, let's see what this one looks like. Make it a bit bigger so we can all read it. Now, 15 to 18. It's positive, negative, 0, a -1 correlation, or a +1. These two at the end area are for perfect straight lines. You know, and a sequence of dots on the same straight line. So if you do the age and height of a tree, the age of a tree and its weight, right? So if you had age of tree and against its weight, it would be a positive correlation, right? The older the tree, the taller it got, right? At least for its growing life. Now it won't be 1. Because some years the tree grows 4 inches and the next year it grows 2 inches, right? It's going up, but it's not a fixed amount, right? It's not a perfect straight line. Now, if you do the height of an adult and the last digit of their social security, what would you expect, if any, connection between those two things? So if you got the height of someone and the last digit of their social security and you plotted those, degree 0. If there's no connection between the two, I don't see why being 67 inches tall should have any relationship to your social security number whatsoever, right? It'd be totally random. And when things have no connection, they have a 0 correlation. Now, the length of a pencil in inches and the length of the same pencil in centimeters. If you did that, would you expect to see a perfect straight line? Like 5 centimeters, so many inches, 6 centimeters, so many inches, right? And a perfect straight line, that's when E would kick in. So when you are looking at correlation, the numbers aren't just 1 and -1. They're just special cases. So if you have data that's going up, but not in a perfect straight line, you can just say it's positive correlation. If it's going up in a perfect straight line, then you can say its correlation is 1. If there is no clear pattern, it's just a bubble with nothingness, then the correlation is 0. And there's negative and -1 as well to go with that. Did that help, Ariel? Is that what you were wanting me to answer? Okay, good. Has anyone else got a question? Ariel's good. Oh, Ariel, is that you thumbs up, or is that you got another question? Let's find out. No, I think those are just thumbs up.
I have a question about the second test.
Okay. Which number?
So for the, I don't remember which number it was, but it was the tree diagram one.
Okay, tree diagrams are always fun, aren't they? So let me go find the tree diagram one. And it's in section 2, as you'd expect. It's in probability. Still looking for it. So it's question 12 to do with the delays in flights, I believe. So let me check question 12. And I've got the answer, but it helps, I think, if I... Why can't I see that damn thing? Excuse me a second. There we go. Right, let's see if we are in this one. Right, here we go. So zooming down to the solutions. And I can maybe talk you through this, right? So on any given day, 30% of airlines flights into the Scotia are domestic and the others are international. So the first branch is domestic flights and international, and 30% is 0.3, and so the other 0.7 must be international. Are you comfortable about the first branch of the tree split in 2 ways and why it's 0.3 and 0.7, right? Now, for each kind of flight, domestic and international, some are delayed and some are on time. So let's see what we get if we read on a little bit further. In the domestic flight, there's a 10% chance of you being delayed. So 10%, 0.1 being delayed. Now, if you're not delayed, doesn't that mean you're on time? So that's where the other 0.9 came from. 10% delayed, 90% on time. 20% delayed, 80% on time. Now, if you go to the next one, there you go. 20% of the international ones are delayed, 80% on time. So this is the tree diagram. And when you can create a tree diagram, each of these little pathways has a probability associated with it. You can then go and find what the destination probability is. In other words, what's the chances that I get a domestic flight and that domestic flight is delayed? And you do that by multiplying the two together, and you see we've got 3%. And domestic on time, 27%. International delayed, 14%. And lastly, 0.7 times 0.8, a 56% chance that an international one will be on time. So it asks you now to fill this table in, and let's see what we have. Domestic, international, delayed, and on time. So let's take that one. That would be a domestic flight that's delayed. You see 3%? That's why that fits there. How about an international one that's on time? An international flight that's on time, 56%. We're good? So, what is the probability that you are on an international flight? Well, isn't the answer to that simply just 70%? And couldn't you also get it by adding these two numbers together, 70%? Given that your flight was delayed, what is the probability that you were in an international flight? Now, since you were told it was delayed, it's those two guys. And the probability that you're international, that goes in the top. And delayed, which is these two added together, goes in the bottom. So that number over that number, that's where that 83 came from. As a decimal point, 823. So whatever is on the bottom, whatever's second goes in the bottom. So delayed goes here. Now suppose I went and switched it round. What's the probability that, well, that's the same question, being delayed. So are flying being, are these two things independent? And they are flying international, right? And being delayed. Well, we know the chance that you are flying international is 70%. And we know that the chance that you're going to be delayed is 83. If these two numbers are the same, they are independent. If these two things are different, as they are here, dependent. So you find the probability of the thing like international, you then find the conditional probability. If they're the same, independent. If the two things are different, dependent. And that's just, God, that's from the probability section to do with dependent, independent. That's a good question. I like that question. Right, Lauren or John or anybody? Lauren, you got a question? Oh, wait a minute, Rob, you've got another question. I haven't asked you for ages. Where are you, Rob? Oh,
I'm right here.
okay. What was the next one you wanted me to do?
The next one was number 6 on 13B.
Third, number 6 on, could you repeat that again?
13B, homework assignment 13B.
Okay, let's go to question 6 then. Just hitting all my usual buttons. (13B), where are they? Responses, gotcha. And question 6. Okay, now let's do this fella. I have all the numbers in front of me, so rather than me jump back and forward and get dizzy, use the output. It's Minitab, but it's just use the numbers in that table to find the unpulled test statistic T. So we know how to get T-score. It's x1 take away x2 over the standard error again. Now, in that table, x1 is sample 1, and the mean is 80.56. And x2 is sample 2, and the mean is 78.54. And it's going to be divided by the standard error. And I'm going to get the standard error of the difference between them by doing that square root thing again. So it's very similar to the first question you asked me about. Now S1 is 4.23 squared over 67. And S2 is 3.33 squared and by coincidence, also over 67. So it's the square root 4.23 squared divided by 67 plus 3.33 squared divided by 67. And the answer I get is 0.658 if you round it to 3 decimal places. That means now that the t-score is that guy. And make sure you put the little brackets around it. So here goes. The first mean, 80.56. Take away the second mean, 78.54. All divided by this standard error, 0.658. And the answer I get is 3.07 to 2 decimal places.
I wasn't here for any of that.
What was that, Rob?
My internet keeps going out. I hear about half of what you say, and I'm off and on. So it's like
This video will be back. It will be put online sometime later this evening.
okay.
But give you a quick rundown of what it was. That was mean 1, take away mean 2. So that was from the table. The standard error was using the same formula you did last time. These are the standard error in the sample size, the other standard error sample size. That's this guy. 2 top guys subtracted, divided by this guy, and there's your answer.
Okay.
So when you are doing the difference between 2 means, if you're interested in getting the t-score, you need to know this formula. And you also need to know how you get the standard error, because this formula uses it. If you've got those 2 guys, then with a bit of practice, you'll be good at it.
Okay. Thank you.
You're welcome. Where else are we going? Who's got my next question? Oh, we may have it in chat because Ariel has issues. Well, someone's asking what equation should we keep in mind for the second part. Oh, someone gave a good link. If you go to Canvas, you get it. Really, every equation that you've got could turn up. See, this one here is how to get the t-score. Just off the top of my head, there are many more formulas, but just to give you an idea, if you were doing a similar question, but it was to do with proportions, the formula looks very similar, doesn't it? Except it's a z-score, not a t-score. So this is for the difference in 2 proportions. So there's a formula. Does anybody remember that guy? The standard error. Okay, bye-bye, John. Any volunteers? It's a big, ugly formula. It's even uglier looking than this one. Last chance. Here goes. P1 hat, 1 minus P1 hat over N1. P2 hat, 1 minus P2 hat over N2. Right. You remember it now? Every time I do a formula and you say, I've forgotten that one, I hope you've written it down somewhere. And it's probably a good idea to write down when you would use it. So you might write something like this. Use when it's the difference in 2 proportions. If you organize them like chronologically, right? Any equations, you know, in week 1 that we used, any equations week 2, 3, 4. Actually, isn't this the equation that gets used in two different places. Isn't this the guy you use in hypothesis test? But isn't it also the same guy that you use if you were doing 95% confidence intervals, for instance? So it's very similar. This guy here gets used in lots of places. Okay, any more questions?
Ariel had another question.
She did? Okay, thanks for telling me. I'll have to go out and then. You think it would have, maybe there's just a way to do it and I just don't know how to do it. It says, could we review number 27? Is it 27 Ariel in the multiple choice or 27 in the section 2? Which is it? Okay, gotcha. It's in the multiple choice. Okay, now let me go in and do our thing. Right, there we go. So it says the mean time required to assemble an electronic component used in CD players is 12 minutes, and the standard deviation is 2.1 minutes. From this, we can determine that at least, and it's an unknown percentage, of the assembly times will be between 7.8 and 16.2. So that's the question. Now let me show you, because it's quite visual, how you would come up with the answer. This is that 68, 95, 99.7 rule being used in a different way. So I'm going to draw the normal distribution that looks something like this. And right in the middle, you have the mean, which in this case is 12. And the standard deviation is 2.1. So that makes that 14.1. Another 2.1 makes that 16.2. And that makes that one 18.3. Now, if you take 2.1 away from that, you get 9.9. If you take 2.1 away from that, I believe you get 7.8. And if you take 2.1 away from that, I believe you get 5.7. And we're being asked to find out what percentage is between here, that's 7.8, and here. Now, did you notice that this is two standard deviations away from the mean? You see that? It's 1, 2 to the left and 1, 2 to the right. What percentage of data is within two standard deviations of the mean?
$95.
And the answer to 95 is E. Are we good with that? So it's the 68, which would be from here to here. 95, which is 2. And from here to here, 99.7. So the question could have been, what percentage would be between 5.7 and 18.3, right? From here to here. And the answer in that question would be 99.7%. Basically, almost all of them would be in that range. Now I have to go out and see if that was okay for Ariel. Is that what you wanted to hear?